Before taking this course of reading and writing in the content area, I was somewhat skeptical of implementing the two skills within a math class. When I thought of teaching math, I just thought of using numbers to solve problems. But now after reading the book Content Area Reading by Richard and Joanne Vaca and Marianne Mraz, I can see how implementing reading and writing skills within a math class can actually help students further connect math concepts. As an apprentice teacher who normally assists with math classes, I had the great opportunity to teach an Algebra 1 lesson in place of my colleague with students whom I've never taught before. So you will notice in the video that I call on students to answer questions and ask them to state their name so I can become more familiar with them. Also, with me calling on students, I utilize the idea of having students read the problems from the book aloud in class. The curriculum our math department uses for our math classes is the College Preparatory Mathematics Core Connections. This curriculum emphasizes the importance of students working within a group. Every lesson is focused on students finding the conclusion or big idea on their own within their selected groups. It was nice to see that the book, the Content Area Reading, supports the idea of students working collaboratively in small groups. As for implementing a writing activity in the math class, I have used the admit ticket idea from Vaca, and Mraz. You will see me implement this idea by having each student answer the question that I have placed on the board in the back of the classroom by writing it on the admit ticket. This is to incorporate more writing and understanding of the student's thought process. At the end of the class, I once again distribute each student's original admit ticket to them and have them flip the card over to the exit side and answer the same question from the beginning of the class. This allows me to see if students have found a better understanding of the focused concept, or if I have been clear in my own teaching, if a student is not focused or stuck on a specific concept. And also in having them answer the same question from before, the idea is that the student themselves will see where they are with their own understanding. Thank you to the students of PVPA, my colleague Joe Agron and Ben Murray for their assistance in making this video. Watch and enjoy.
We're going to start class today with a warm-up. So if you can look up here on the board, it says write the area of each generic rectangle as a product and a sum. Go. As a group. So talk about this sum. So let's start with A. So we're going to write this as a product and a sum. The inside of the square, this is going to give you your sum, right? So if you add them all up, you'll have the sum, the area of this rectangle. How do we go about finding the product? So how do we go about finding the length and the width of this rectangle? Anyone? Bueller? Yes, what's your name?
Noah.
Noah, hit it.
To find the product, you must you find the length and width. You find what multiplies to equal each box, and
Yes.
then it's like a puzzle. You have to plug in.
It is like a puzzle.
To work out. It has to work.
So I think what Noah is trying to say is that you have to find the greatest common factor that goes into 2 and 5, and also 2 and 6. 2x and 6x squared. And then you have to do the same. 5 and 15x, and 15x and 6x squared. So you need to find the greatest common factor. I'll just draw these little arrows this way. Do you see that? Feel free to write this down in your notes. So you can. So now we can see that we have the length of this rectangle and the width of this rectangle. So in order to find the product, we do length times width, correct? So now let's figure that out. So we have 3x, I'll write it down here, plus 1, right? Multiplied by the width, which is 2x plus 5. This is your product. So, like we said before, how do we find the sum? Addition. Thank you. So you add up all 4 parts of the rectangle, yeah? That's 17x plus 5. And this is your sum. So So do we see the steps in how we came up with finding the product and the sum?
Yep.
Using a generic rectangle. Guys, on your desk, you should have these note cards. Everybody take one, write your name on it, and write it on the admit side. Okay, so it says admit. You're going to write on this the question that's on the back. What can you tell me the answer to the question? What can you tell me about the distributive property and so open your books to page 466. You're looking at 8-4. Can I please have a volunteer to read 8-4 out loud? Or I can pick someone.
Well,
Yes, Maddie? Is it? Maddie, go.
While working on problem 8-3, Casey noticed a pattern with the diagonals of each generic rectangle. However, just before she shared the pattern with the rest of the team, she was called out of class. The drawing on the paper looks like the diagram below.
All right, so listen. As Casey was, writing on her generic rectangle, she's like looking at it thinking, oh my gosh, I don't know, there might be a pattern. So let me just circle these diagonals. But oh wait, I left my cranberry CD in the quad. I didn't run. She left it like this. In your groups, take a couple of minutes to see if you can figure out if Casey is on the right track of finding a pattern. Okay? So try to figure out what the pattern is in your groups.
You guys can talk
That
about
means work together.
it. No, you didn't.
And we figure out a pattern. Yes. What's your name again?
Anna.
Anna, sorry.
Yeah. 2x times 15x is 30x squared.
Okay.
So it's 6x squared times 5.
Oh. So, Anna, are you trying to tell me that these two diagonals, that each diagonal, that they're equivalent?
Yeah, they have the same product.
They have the same product? Really? Huh. No way. How do we see, how are we going to see if Casey's theory is correct?
Use it the other problems in the paper.
Yeah, so let's go back to 8-3. And let's do B and C in your groups and tell me if her theory works.
All right, let's do it.
Okay, so yes, it does work?
Yep.
So we can pick some generic factors inside of this generic rectangle. You like my wording? Okay. So we can pick some and say AC times BD will equal ACBD, and AD times BC will equal ADBC. And that these two equal each other. Do you see that? And it doesn't matter what order it's in because we're multiplying. So you might want to take out a pen and paper and write this down. This is our first pattern that we're noticing about the generic rectangle. Isabel's going to read 814.
8. Factoring quadratic expressions. To develop a method for factoring without algebra tiles, first model how to factor with algebra tiles, and then look for connections within a generic.
Figure out how to make a rectangle using those tiles. So, if you do not have it, I have demonstrated this for you on the board. And I have noticed that some of your rectangles look a little different. That's okay for now. But I'm going to explain to you why I set mine up this way. Okay? So before I do that, let's figure out what the length and the width is, the product of this rectangle. So who can help me out? Okay, so when we write the product, what is it going to look like? Somebody say it out loud to me.
What's the product? Oh, yeah.
Well, yeah,
Well, positive 1.
I'll do X.
X plus 1.
Uh-huh.
And then 2x plus 3.
Okay. Thank you. There you go. There's your product. Got it? Now, before this, we were talking about our generic rectangle, right? Yeah? So check this out. Check this out. Check what I'm going to do. Check it, check it, check it. I'm going to erase this really quick. This is me writing my generic rectangle. Okay. So then I said 3 because because that's 3 unit tiles, right? Look at this. Remember I said you want to always put your x squared tiles in the bottom left? Do you see why? And this is your generic rectangle. So the amount of tiles match up with the numbers within the generic rectangle. Do we see that?
Anticlimactic.
Wait,
So do we understand that? Yes.
is it saying negative 3x or is that?
That's just a
No,
smudge.
that's just a smudge. There, I got it off. Sorry.
So if
Thank
you
you.
blanket, leave it just.
Ah, yeah, if you blanket, bam, 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 boo. Gotcha.
Bamboo.
Do you see that? All right, guys, listen. So now that we figured out that we can use our algebra tiles to fill in the generic tile, we're not using the algebra tiles anymore. We're going to just do the math without the handicap of the tiles, okay? So let's look at 814, part B. Someone read the paragraph starting with Miguel. 814, part B. Read the paragraph that starts with Miguel.
Oh, okay.
Yes, name. Rachel, go.
Miguel wants to use a generic rectangle to factor 3x squared plus 10x.
But we're missing something. We're missing the 2 middle tiles. Yeah? So tell me if this looks familiar at all to you.
I love those. Yeah.
The diamond problem. Shine bright like a diamond. Yeah? So, do you remember these? So, x, y, the top of the diamond is the multiplication, the bottom of the diamond is the addition, and these are the factors themselves. So we know the pattern of the generic rectangle, that the diagonals have the same product, right? Yeah? Are we all together?
From 8-4 earlier today.
So what's 8 times 3x squared? Shout it out.
24.
24x squared.
24x squared. So, what was the first pattern we figured out? The product of each diagonal is going to be equal. So the product of these 2 missing squares are going to equal 24x, right? So we can say, we can make a diamond problem and say, this top part will be 24x squared. Now, if we take x and y, we also need it to add up to something. So can we think of 2 numbers that factor into 24x squared when you multiply them, and also factor into 10x when you add them? 2 factors, or numbers, or factors, or numbers. You see how I'm using those words together? Go ahead, I haven't heard from you today. What's your name?
Emma.
Emma. 4 and just regular 4 and 6?
4x and 6x.
4x and 6x. Do we agree?
Yeah.
So we're gonna put 4x and 6x here. And this gives you the 24x. So now that we have all of it filled in, you can find the sum through going through all 4 from adding all 4 up, right? So walk me through it. What will I add up? So we started out with class with just the regular generic rectangle and figuring out the product. And now we can use the sum and we can factor out what the product is going to be. And now you also know how to take the product and distribute into the sum. So we have our big idea. Now we know how to use our generic rectangle to figure out the product and the sum. So I'm going to hand these back to you, and on the back, you're going to answer the same question you did for the admin on the back of this card, okay?